Hello. Hello, hello. So Fuzzy, you just have to upload all the files and then type make. And then the name of the file is different. It's vert under. It's like this, I think. It is kind of mentioned in the PDF there at the end. The object code I think is called. So I think you just do / vert aqua, and it should work. Hello, Brandon. Welcome. Bring that over there. What's going on here? There we go. That looks good. Should be good. We got Scary Face back. Guess we'll put that away. Goes there. Yeah, Deborah's lurking in the background there. All right. Close that. We can bring it over here maybe. Let's try it. Maybe we'll try something new today. Okay, let's turn that off. Hello, everybody. Welcome. There we go. We've got quite a few people in here. Chef, good morning. Hamma, hello. Synthos, good morning. Turbo, hello. Hello, Yang. Welcome, everyone. Kane, hello. All right, looks like we got everyone here. Morning, CS202 student. Giovanni, welcome. Nick, welcome. What do you say we do notes in VS Code today? Cade, hello. That looks kind of nice, don't you think? We'll try that out for a little bit. Mix things up a little bit. So, Welcome. Today is Tuesday. We're starting a new subject today. That is operator overloading. Before we get on with that, there's maybe a few things to talk about with the current assignment. A lot of you have been figuring it out. I think, as many of you have discovered, it's not all that terrible, but there are a few kind of confusing things. The professor who made that included some comments in there, right? And those comments have been a little bit confusing to some people, so I will just briefly mention one of them. Pull that open. I think that's here. So here in the tank.cpp file, you'll notice this huge kind of piece of text. And Sam asks you here to check to see if the fish will go out of bounds. Now, this is not very easy to understand. I'm not quite sure what he meant by this. But you do want to check to make sure that the X and Y, the X and Y are both, if they're less than 0, then obviously you've gone out of bounds. You also want to check for if the X, say, is greater than equal to, say, the width, or if the Y is greater than or equal to the width. So that's a bit of a confusing statement there. Just check to see if it's gone out of bounds. You know how to index an array, all right? Just check to see if it's gone out of bounds. Try not to pay attention to whatever that says. And then the second thing is, if you notice here in this, what do we call it here? This draw tank function. Sam is doing this by height and then by width. Okay, so in class, the example I gave you, I did width first and then height. So you have to swap them. So if you kind of copied the in-class example, the best thing you can do is swap them. All right, do the height first and then do the width. Now, that being said, there's one more thing I want to mention. And I just want to ask you guys, because I didn't really talk about it. I want to see if you guys understand what's going on here. Let's see, that's the tank object. Why does this have to be a triple pointer? Why does this have to be a triple pointer? What do you guys think? Pig, I'll get to your question in a second, but can you guys tell me why this has to be... What's the point of the triple pointer? Why can't this be, say, a double pointer? So, yeah, we know that it's two-dimensional, right? We know that it's two-dimensional. But I guess my question then is, why does it have to be 3 stars and not 2 stars? And you guys are saying because it's a grid of pointers. Why do we have to use the pointers? Why can't we just do a double star? Why are we required to use the pointers? Because this is kind of confusing at first, right? But what's the point of using the pointers? All right, Chef, that's correct. So some spaces can be empty. That's part one. So if you think about it, it's a two-dimensional grid of pointers. And some of the pointers can be empty. We're going to pretend that that's like water, right? That's water in the tank. There's nothing there. But what's the second part? Right, Hannah, that's correct, right? To differentiate between an empty space and a fish. But there's a part 2 to it. Why else do we have to use pointers? There's a part 2 to it. Reason 1 is so things can be empty. What's part 2 to it? Well, it's because we are using virtuals. Do you agree with that? Does it make sense? If you kind of look in these skeleton codes here, let's take a peek. Look what comes up here. This is angry at me because I didn't include the prototype for that yet. But look, this is an enumerator, by the way. I don't teach this. All right, it's just like a for loop. I don't know if you want to do, say, for int I equals 0, I is less than fishlist.size. That's basically what this for loop is here. All right, so don't be scared by that. This is basically just a for loop for all of the fish in the array. Look, though, this is a pointer, and we're calling swim from it. We have to use pointers because we're using virtuals. That's a 100% requirement there. We're using virtuals. We're using base class fish. What are the derived classes? The horizontal fish, the vertifish, and the wall fish, right? Those are the derived classes. So when we call swim from the base pointer, we need to make sure that we are referencing the correct derived class implementation of that. Pig asks, what part does a pointer play in a virtual? It's just a requirement by C++. We talked about that last class, and the one, I guess, before that, is that if you want to do a virtual function, you have to use a pointer to the base class. That's just how C++ made it work. We kind of talked about that last time, you know, from assignment 3, if I were to say player P equals red player, and then I said, hey, P.doDamage. Here I'm going to be calling player.doDamage. All right, it's not the one I want. It's not the one that I want. And that's because I assigned a red player into a player object. If I want to make sure that I call the red player.doDamage, I have to use a pointer. I also have to make sure the doDamage function is virtual. So if I were to convert this to use virtuals, I have to use a pointer. It's a requirement. I have to use a pointer. And then I have to say P.doDamage. So it's just a requirement. That's all I can really say about that. If you're going to use virtuals, you need a pointer. Would it be correct to say we use the pointer to the base class to store pointers to a derived class? That is 100% correct. That's 100% correct. Let's look at it. Where am I? Doesn't look right. Maybe it is. These are the notes from last class. Let's find it. Virtuals. There is always a pointer to the base class involved. We will be storing objects of the derived class into the base pointer. Always, yes. Chef, that's literally what we said. Yep, that's always how it works. And that's what this assignment is. You have a fish pointer. And inside of that fish will be different fish. All right? All of your video games use that stuff. So, I do want to read this. Pig asked, what function is the height versus width thing for? It's the constructor. In the tank, you have to allocate memory for the tank. All right? In this class, there's a pointer. And you need to allocate it so that it can store fish in it. And so in the constructor and in the destructor, you will be allocating and deallocating this object. Or I wouldn't call it this object, but this 2D array. And it matters if you do the height or the width first. It matters if you do the height or the width first. Because Sam was nice enough to give you some functions here. Like, say, this draw tank function. And the way Sam has done this is he says it's the height first. Notice that the I is corresponding to the first dereference. So you need to make sure that you allocate it the same way. If you don't, you'll get some issues. So I think that assignment is due tomorrow. I know a lot of you have finished it up. Is there anything you want me to talk about? Or is there any confusion? Was I able to answer some questions here? What do you think? Hopefully it makes sense what's going on here. And that the reason that we're using a triple pointer is because we're using virtuals. That's the whole point of the assignment. And the base pointer is a fish pointer. Hannah says, would it be the same for deallocating? Yes. you're going to want to deallocate the each element first. That is the elements that have fish in them. It's like backwards. So you're going to, in the constructor, you're going to allocate the height and then the width. And then in the destructor, you're going to deallocate all of the individual fish. And then you have to deallocate the width and then the height. So it goes height, width, width, height. Is the code grade link on the assignment 5 in Canvas? I think it is. You have to scroll through all of that that whiteboard stuff that he made. I can go check that. But I think it's there. You just have to scroll through all of his... he did a little whiteboard there talking about the two-dimensional array. I already went over that. So obviously you can kind of skip through that unless you want to look at it. But if you scroll all the way through it, it should be there. See? You just got to get all the way down to the bottom. Come to office hours or message me after class and we'll figure it out then. Does anyone have the same issue? Just so I know. Because I think it's working. Yeah, quite a few people have turned it in already. So I would say I'll help you after class. It looks like it's fine. So if there's anything else, let me know. Other than that, we're going to get started with class today, okay? So today we're starting a new subject called operator overloading. This is a little bit similar to, say, overrides and function overloads. Function overloads. But before we do any of that stuff, we're going to need to learn about friend functions. All right, we haven't talked about friend functions yet. This is going to take us just a little bit of time here. Not too long at all. So I am going to make a little code for this. All right. Now, friend function is any function declared outside of the class. So it's any function declared outside of, say, class A. Let's do that. Any function declared outside of class A, all right, that is specified to be a friend of class A. You see, this is why I'm not having a good time here. I thought this would be fun, but we'll see. A function declared outside of class A that is specified to be a friend of class A has access to class A's private variables. Private and protected, that is. Okay? So that's what a friend function is. All right, so basically it's like any function. Let's do some syntax for that. You can say have class A, and you can have some private or protected members in class A, say int x. And then down here you can have something like void foo. And what this function has to do is it has to take an A object, that is. Likely you're going to want to pass it by reference. Okay. And in here you're going to be able to say, hey, param.x equals, say, 5. And that's your modifying a private variable. Now, you can't just do that right off the bat. You're actually going to have to come in here to this class somewhere. Anywhere works. It doesn't have to be public. And you have to say, hey, friend void foo a by reference. So this is the friend function. All right, and then this is the actual function. So we'll do a fun little example of that, okay? Now we have to use friend functions for operator overloading, and we'll get into that. Hema asks, do we need to run the ./a.out? It's the vert aqua. That's the object code that it makes, is vert aqua. Unless you're compiling it on your own without the make file, it makes the object code is that vert thing there. So that's it. Does anyone have any questions on friend functions? If you just want to see how it works real quick. Of course, not the most exciting thing in the world. We're getting into the most exciting stuff in just a moment. I can say take my class person and I can have private and public things, right? So let's assume that we have, I don't know, a parameter constructor that takes, say, a name and an age. And up here we'll have, say, a string name and an int age. And if I want to initialize them, let's do it the special way. What do you say? Hopefully this doesn't confuse anyone anymore. I'm just initializing those variables, right? So let's say that's our constructor. We can make it a little one-liner there. Now, notice it still has a body. This got some people on the test. Notice this function, this constructor is still doing stuff, right? This part of the code here is initializing those variables, right? We actually don't have to do anything in the body, but it needs to have a body. If you do this, your compiler's not going to be very happy with you because it doesn't know if this is the prototype or if this is the actual constructor definition. So you do need that little empty brackets there. Now, if we wanted to, we could make a void update person function that takes a person by reference, P, and then say it takes a new string name and it takes a new int A. And in here, I want to say P, N, our name is equal to N. And I want to say P.age is equal to A. Now, obviously, right now, it's mad at us. All right? And if we go to Bobby and try to compile this code, it will obviously be mad at us. You guys know this, right? You know it will be mad because those are private variables. Those are private variables. There's no way that this thing is allowed to touch those. But we can make it work if we want to. We can make it work if we want to. Now, you might ask, why don't we just make a void update person in here? And to that, I would say, I think you're right. All right. Personally, I think you're correct. But like I said, we need friend functions for operator overloading. So this is just to show you that it works. That's all. It's just to show you that it works. And that's it. So we can go ahead and take it to Bobby here. Of course, I can try to compile it. What are we looking at here, friends? And of course, it's private, right? So let's fix it very easily. We just come up here and we're going to say, hey, friend. And then you basically just copy this. That's what I would do. And then you're done. Save it. Take it back to Bobby. Clear. Recompile. And it works. Any questions on friend functions before we move on? I just want to make sure I got that right in the notes. Friend functions, it's any function declared outside of class A that is specified to be a friend of class A, has access, so will have access to class A's private and protected variables. Hammer says a friend function doesn't need a body of code. Yeah, it does, and it's there. This is a global function, okay? This function is global, as it is right now. So it follows all the rules of a regular function. This is simply specifying, it's kind of like you need the friend and then the prototype of that function, whatever it might be. So inside the class, you need to type friend and then the prototype of the function that you want to be friends with. Does it make sense? Inside the class, you need to type friend and then the prototype, or the header, right, of the function that you would want. Synthos says, so the update person could be used in main everywhere else since it's global. That's correct. Notice here I'm calling it. Notice I'm not doing p.update person. I'm not doing person dot update person. This is just back. We're taking you back to CS135 here. We're not dealing with any. Did we die? Of course we died. Thank you. Okay. Sorry about that. Of course, that'll probably be our only little hiccup for the day. So back to Synthos' question. This is just a global function, right? Like any function that you've ever typed in CS135. It's a global function. And just that we specified it to be a friend, that means that we're allowed to access any object of that class. We're allowed to access their private variables. That's it. Obviously, I have to pass in the object that I care about, right? Obviously, I have to pass in the object that I care about. We could probably even do this if we wanted to. Static int, I don't know, person count. All right, now this is a static variable, right? This is a static variable. So if I want to initialize it, I can say int person, and then I say, I don't know, person count equals 0. And then if I want to increase that count every time I declare a person, I can do this, right? This is nothing new. And then I could say, make another friend function. Void print person count. Now this one won't even need to take any parameters, right? Because this is a static. This is a static variable. But notice that it is private. So somewhere in main here, I'm not allowed to say, hey, how many people do we have? I'm not allowed to do that. This is private. It says this is private. It's inaccessible. I don't have access to this. So similarly, if I were to put this in a function, I'm not allowed to do that. Unless I make it a friend. So I'll just copy C here. I'll say, hey, you are a friend. And that will make this work. Does that answer your question, Synthos? Obviously, I'm, I don't know, bamboozling you all right now. We've spent this whole semester learning how to type functions that apply to the object, and now we're just back to making global functions and whatnot. But you'll see. You'll see. Don't be fooled. Oh, yeah, I have seen that meme. I have seen that. I don't have TikTok, but I do catch those on YouTube occasionally. I don't know if that was a Vine or not. Whatever. So now we're moving into operator overloading, all right? Now there's a lot of stuff involved with operator overloading. And the way to put it is that operator overloading itself is a simple concept, but there's a lot of operators and there's quite a few things you can do with them. Okay, so let's go ahead and get into that. Operator overloading is one of my favorite things in C++, so I hope you're as excited as I am. Let's take a look at what we're working with today. Those are our notes. I want to look at the other notes. All right, so let's just kind of declare a few things, all right? You guys know what these things mean, so please tell me. What is LHS? What is the RHS? Please tell me that. I'll define the operator for you. I will also define the operand for you. We've talked about that stuff before. All right, so tell me what the LHS is and the right HS is. An operator is a symbol that represents some function, right? Left-hand side, right-hand side, all right? We're going to be talking about this a lot, all right? We're going to be talking about this a whole lot. So be prepared, all right? We're going to be talking about this all the time. I'm going to say what's on the RHS, what's on the LHS. So you need to know what those mean, okay? Left-hand side, right-hand side. What's an operator? It's a symbol that represents some function. So what are we talking about? We're talking about plus. We're talking about minus. We're talking about star. We're talking about the dot operator. All of these things, right? It's math. Your favorite thing, right? Plus, minus, star, whatever. What are some other operators we know? The arrow operator. Wow. We know the bracket operator. Amazing. The parentheses are also an operator. I can keep going. Okay. Let's go to Ramhog here, Chrome. And I can type in C++ operators on Google. And I'll go to c++.com. And I'll scroll through here. And whoa, what did I find? Don't full screen, please. Found a whole table of all operators in C++. Not only do they tell you the precedence, meaning what happens first, right? It says the plus plus. Looks like it has, or the scope operator actually has the highest precedence. Meaning it will check your whole expression and it will look for the scope operator first thing. And then you can see all of these, right? You guys know this. Look, it considers new and delete to be operators. It's interesting. Size of, I told you, is an operator. Type, C-style type casting, right? We went over that previously. Those are kind of the parentheses. That's considered an operator. Okay, so we've got all of these C++ operators. If you want to look at them, here they are. Now, when we talk about an operand, these are the arguments supplied to the operator. All right, you guys know this, right? What is the operator operating on? They're kind of like parameters, right? So Chef asks a good question. Is the colon included in there? And I think we looked at this previously, and I'm 90% sure it's not. I just died, didn't I? I gotta stay off of Google Chrome. I'll let you look, okay? My computer froze there for a second, so I'm gonna avoid. Yeah, I'm gonna avoid that. You guys back? Hopefully you can see me. It looks like I'm here. It's because I was disrespecting Google Chrome. I was going back to that operator stuff. I'm going to let you do that. I'm going to stay away. I'm going to stay away from Google Chrome for the rest of the day, okay? All right. So, Chef, to answer your question, I don't think so. I don't think it's an operator. I don't know what it's considered, but I don't think it's an operator. So, coming back to the operand here, it's the arguments supplied to the operator. All right, they're kind of like parameters to a function, right? Similar to parameters in a function, right? So if we take some examples here, let's look at A equals B, right? A equals B, well, our operands are A and B. I don't know what, see, this is, bleh. Our operator is the assignment operator. Let's look at another one. A, B, right? Similarly, the operands of this are A and B. The operator is the parentheses. Okay, so you probably haven't seen that one before, but this can be applied to anything, right? We're talking about brackets, we're talking about plus, minus. This one, did you know that this is an operator? Cout my string. Let's see if you know this one. What are the operands and what's the operator? What are the operands and what is the operator? This one might get a few of you. It's a good one. Okay, that's a good one. All right, so the arrows. Okay, so we're going to go. Yeah, okay. So Chef and Giovanni are correct. And then I think Pig, you're saying that Cout is the Well, yeah, so most of you are getting it here. That is our operator. The operand is Cout and my string. This is an object. This is like a, I wouldn't call it a variable, but it is an object representing the terminal output. So in fact, Cout is an operand, right? You've used stuff like this before when you say something like my file, right? My file, read into my string, right? So that's like similar. So those are all operators. If you want to go look at them, there it is, right? If I try to pull that up on any sort of internet, we're going to have problems. Now, I ask you a question. We have used operator overloading before. Now, I'm not saying that you have defined your own operator overloads, but what are some examples? Chef asks if we have Cout my string X is the operand with X still Cout. So that's a good question, and I'll just show you how that works. If you take A plus B plus C, this can be decomposed into, say, D plus C, where D is equal to A plus B. So in a way, Chef, A plus B is just, plus is just a binary operator. And once you evaluate it, then you're stuck with another binary operator, where C is the right side and A plus B is the left side. So if you're talking about Cout my string X, the operator is still this, and it's a binary operator. And we're going to learn that this actually returns Cout. You're going to learn this today. This, my string, it's an operator, and it returns the string, or the stream. It returns the stream. So this is kind of equivalent to Cout. So in a way, this happens first, and then this part happens second. I know that was maybe a little confusing. Did that answer your question, Chef? The operands are still X, my string, and cout, but it's a binary operator, and it kind of evaluates one at a time. So the first thing it evaluates is this, and then you'll see what it does later today. I'll show you. This essentially becomes a cout, and then it will then cout the X. So I'm glad we could talk about that. Like I said, you'll see it later today or next time. We'll see how much time we have. So Pig suggests maybe class dot. Okay. I won't go with that. Let's see. Giovanni says, when an operator has more than one job, yeah. So, what I'll say with that, that's smart. When it's a binary, right? When you have A times B, it's multiplication. Multiplication, right? So that's a binary operator. So when it's used with two operands, it's multiplication. When it's used with only one operand, it's dereference. So it's similar to function overloading. So, you get a gold star for that one. Not going to lie. You get a gold star for that one. But I want you to think about in terms of classes. When have we used operator overloading in terms of classes? We have used a few classes before. Okay. We've used a few classes before. Let's think about the classes we've used. We've used strings, right? We've used vectors now. We have used F streams. Now, have we ever used an operator with one of those? What do you think about string? String S and B. What kind of operator have we used before with that? We can use a few operators. I don't know. Let's think of a few. Cout S plus B. You guys know what that does. Cout S at 4. Yeah, Synthos. There's a little bit of a delay, but I know that you got it. So gold star to you as well, right? You can do a vector, right? Vectors have the bracket operator. F streams have the insertion and extraction operator. So do you believe me now? We've done function overloading before. It exists. You've used it. But now we're going to learn to do it for ourselves. We're going to learn to do it for our own classes today. Okay? So let's get excited. All right? We can overload operators in C++. That's the first thing we can do. We can overload. I'm going to call them ops for our own classes in C++. All right. Now, we can only use the operators that are in C++. We cannot define our own operator. We cannot define our own operators. If you're going to do this, just use a function. All right, just use a function. If you want to use some special name, all right, just use a function. The reason you can't do this is because you don't want to confuse the compiler. The compiler knows only the set of operators. All right, you can't just throw another one in there and expect it to work. All right, so you have to use the C++ operators. We cannot define our own. You must use the C++ operators. Now, you can overload every single one of them except for a few. All right, I'm just going to copy paste this little bit here. so you can reference it. All operators can be overloaded except for these 5. The dot operator, the ternary operator. Some of you guys see the ternary being used in your assignment 5, huh? I know I talked about ternaries before. Is that scary? The ternary operator? They're kind of cool, aren't they? I challenge you to try to use those when you can. I'll show you where they are. Give me a second. I think they're in the fish, maybe. Let's see. Where are ternaries? Here they are. Here's a ternary. Right there is a ternary. There's a ternary right there. Right? So previously I didn't make you, but you could use it for the absolute value, right? In the previous assignment. So the ternary is basically saying you're going to take this draw character and you're going to assign something to it. Right? You could have an if statement that says if facing up equals true, I want the draw character to be equal to this. But if the facing up is false, then I want my draw character to be equal to this. So you're basically condensing an if statement. The if statement becomes one line. It says, hey, is facing up true? If it is, you get this one. Else, you get this one. That's what ternary is, all right? And so you'll see that it's a question mark colon. That's what I'm talking about here. Question mark colon, the ternary. So you can't overload that one, okay? You can't do it. The scope resolution, you're not allowed to overload. This looks like a function to me. Like I've made this complaint many times. But you can't overload these if you want. But I guess you could overload new and delete if you wanted to. That's interesting. So those are the only operators that you cannot overload. All right? Those are the only operators you cannot overload. Now, what are the requirements to begin operator overloading? What are the requirements? Well, you need a class or struct that you declared, all right? You need a class or struct that you declared. And then you need a C++ specified operator. Those are the requirements to operator overload. Now, there is one thing we need to consider. And this is going to be a little bit confusing for some people, so let's please pay attention here as much as you can. This is going to be a little bit, as I said, confusing, so we need to really focus on this. Now, operator overloads are like functions. Operators are like functions. What do I mean when I say this? I mean that operator overloads can be global, but they can also be members of a class. Now that's wild. Well, let's start by making our very first operator overload. Let's start by making our very first operator overload. Let's say, just for fun, I want to do something goofy. I want to say string s, I don't know, equals Patty. And I want to say int x equals 4. And I want to say, hey, when I print s plus x, I want to see the length of Patty plus 4. So what I expect to see here is maybe 9. Of course, this doesn't make sense. If you look at this, it's going to say, no operator matches these operands. You see that error message there? No operator matches these operands. So let's make an operator overload. Now, I'll get the syntax in the notes in a moment. But what type is this going to return? I said that this is going to return the length of the string plus this integer. So it's probably going to return an integer. Now, what is the name of this function? Well, it is an operator. What's the operator that we're using? Plus. What parameter does it take? Can anyone tell me? What are the operands that this is going to take? All right? What are the operands that this takes? Of course, we're a little bit... there's a little bit of a delay, so I'm going to start kind of typing this stuff out while I'm waiting. All right, you guys are right. All three of you are, 4 of you are correct. Operator takes a string and an int. Now guess what? This doesn't work. All right. Look, it went red again. So what does that mean? The order of the operands matter. Okay? The order of the operands matter. Let's just put this in bold. The order of the operands matter. All right. So let's say we do both. Why not? Let's do a string s and an int x. And then here we can do this. String s. So obviously up here, I'm just going to return, say, s.length plus x. And what do you know? That's our first operator overload ever. Seems we got some people back there. My connection is poor. We're going to wait it out. All right, are we here? Are we alive? No, we're not. That's a problem. Yeah, Patty may have stepped on my router. I do pay my